Hello everyone. Welcome to this first session on data structure. My name is Pradeep Pujari. I work for Walmart Labs as a principal machine learning engineer. I used to teach math and physics to undergraduate students in India for about 2 years. I love teaching and mentoring. Here I mentored interns in our company for last 2 years. I am also a project reviewer and mentor for AI nano degree program at Udacity. So now you guys introduce yourself. Please start with the first row. Tell your name, what is your favorite subject and why, and then why are you interested in machine learning. Please start. Thank you. Hello. Yeah, let us start. Today we will discuss about an important data structure called binary tree. Binary trees are hierarchical data structures, whereas arrays, linked list, stack, and queues are linear data structures. So this binary tree, if you see this picture, it has 5 nodes, and the first node, this node is basically called a root node, and this has a left child and a right child. If you see this, these nodes are nothing but the leaf nodes because they do not have any children underneath. So there are two things here. One is the node and a pointer to another node. So we have to represent, we have to write a class or Java code to represent a node, and that can be done. You can write like class node integer, which is basically the value. This variable will hold the value of this 2, 5 or 8, whatever the value, and the pointer to another node, left node, can be represented like this, and the another pointer to the right node can be written like this. And we have a constructor which will basically update the value of the node. So in the constructor you can write key, this dot key equal to this key. Any confusion anywhere? Any question so far? Thank you. Another important thing is about the properties of binary tree. So the important property of a binary tree is maximum number of nodes in a binary tree of height h is 2 to power h minus 1, and maximum number of nodes at level L is 2 to power L minus 1. Just remember these two formulas. We will come and derive the formula later on. Now another thing I want to tell you is about the tree traversals. There are basically 4 types of traversals which can be done on a tree. One is the in order traversal. That means first you go to the left, then the root, and then the right child. In a pre-order traversal, first you print the root, and then the left child, and then right child. In a post-order traversal, you first move towards left, then the right, and then finally is the root. In case of a label order traversal, we traverse a particular label and print each label from left to right. Then we have I will explain with code the in order traversal. you will implement the other tree traversals yourself. Sounds good? Okay. Given a binary tree, print its nodes in order traversal logic. So we can represent this method as print in order, which takes a pointer to the root of the node, root of the tree, and this is a recursive algorithm where we can call this method by passing appropriate nodes or pointer to the node. So this is the exit criteria to come out of the recursive loop. If root is null, then return. Otherwise, go to the left. So it is recursively calling this same method, passing the left pointer to the left child or left subtree. After, when it goes all the way to the bottom or leaf node in the left, then we print that, because in order traversal, first we have to print the left node and then the root and then the right. So so we print that left node here, value of the left node here, and then we again call the print in order, the same method, by passing the right subtree for this. So so this is how the in order traversal code looks like. And if you think the time complexity of this algorithm, it is order of n. Thank you. Now let us do a quiz. How much time it will take to traverse an empty tree? Who will answer this? Yes? Constant time. That is right. So it will take a constant time because it is an empty tree. Okay? Thank you. So let us see an example. How it will look in case of a in-order traversal. So this is a tree. This is the root node, and it has a left child and a right child. So it is basically 1, 2, 3, 4, and 5. So in case of an in-order traversal, the output will be, so 4. First it will go to the left. From root node it will go to the left child, and then left child recursively. Here it will be coming out of the recursive loop, because the root of child of this 4 is null, so it will come out of here and print this 4. Then it will go to the it will print the root node, and then it will go to the right child. So that way it will print actually 4, 2, 5, 1, and 3. Any confusion anywhere? Any doubt? Okay. If you consider the same example and apply the pre-order traversal to this same tree, you will get something like 1, 2, 4, and 5, 3. Similarly, in case of a post-order traversal, you have to go to the left first, then right, and then at the end root will be printed. So the output it will print is 4, 5, 2, 3, and 1. Now how to measure the depth or height of a binary tree? So in order to get a height of a binary tree, we can write a small code and see how it works. So here this is a method called getDepth, which takes a pointer to the root of the tree, and again it's the same way. If root is equal to null, then return 0. That means the height is 0. Okay, and otherwise go to the left or find the height of the left subtree and then find the height of the right subtree and then take the maximum of these two. That will give you the height of the total height of the tree, and we have to add 1 because when we go recursively to the child and another child like that, then we have to add 1 to that. So this is how we compute the height of a binary tree. So another important concept we will discuss today is a variant of a binary tree, which is called the binary search tree. Binary search tree is a binary tree where each node satisfies the following two constraints. That means the first constraint is the key on any node is larger than the keys in all its nodes in the left subtree. Similarly, the key on any node is smaller than the keys in all nodes in the right subtree. Then the third property is left and right subtree must also be a BST, binary search tree. There must not be any duplicate nodes in a binary search tree. So a simple application in search a key in BST. This method will search a given key in a BST. So we will write a code to search a key whether that value is exists in the BST or not. So this is how it looks like. If root equal to null or if root matches the input value, then that is we have to return. And if the root of the key, root.key, that means the value of the node is less than the given key, then we search right side. Otherwise we will search on the left side. So this is again a recursive way of finding a node which matches a given key.